All right, so increasing, decreasing, or constant. That is talking about what is the function doing as we move from left to right. So let's go back to that very first graph, that linear function. As we move along our graph from left to right, we want to start at our leftmost point that we can see and follow our graph. So what is our function doing? Increasing. Okay, it is increasing. So the key here for increasing and decreasing is you always go left to right. So this one is increasing, but you got to tell them where. Okay, this one's obviously increasing everywhere. So we're going to use our interval notation to say that that's happening from negative infinity to positive infinity. Now, the key is we use this is talking about x values. Okay, the y values are the ones that are doing the increasing, but we use the x values to identify where it is happening. Okay, it is happening from left to right, negative infinity to positive infinity. That'll clarify here in a second when we look at this one. All right, so when we get to our quadratic function, it's not always increasing or always decreasing. It does a little bit of both. So we're going to have both of these intervals here. We are increasing part of the time, and we are decreasing part of the time. Now, here's something that I think will help a lot of you. Since you have the graph right there in front of you on your paper, I want you to take, and I want you just to draw a dotted vertical line through the point where this changes from increasing to decreasing. So as we move left to right, it changes there at its maximum point. At the apex of that parabola there is where it changes. I want you to draw that line, and I want you to go all the way down to the x-axis. Sometimes you might have to go all the way up to the x-axis because I want you to identify that x value, and in this case, that x value is positive 1. So as we move from left to right, so we start at negative infinity over here. As we move to positive 1, our graph is increasing. So from negative infinity to positive 1, it is increasing. I use a parenthesis there with the 1 because at 1, it's changing. Okay, it's neither increasing nor decreasing. It's changing between the two. So we always use parentheses on our increasing and decreasing intervals. And then from positive 1 all the way to the right over here to positive infinity, our function is decreasing. This is what messes with people, because we're saying our function is decreasing, so we're looking at the function and we're thinking, well, it's going down to negative infinity. You are correct. The function itself is going down to negative infinity, but we use the x values to show us where. So in terms of our x values, we're looking at positive x values over here, for which our function is decreasing, going towards negative x values. Right? So you use the x values to indicate your intervals. I'm going to keep saying that, so hopefully you remember. This is a struggle every year. All right, let's look at our square root function here. Left to right, it's increasing the whole time, right? But we're not putting negative infinity to positive infinity, because this function does not go to positive infinity. It stops at what x value? 3. Okay, it stops at 3 for its x value, so it's increasing from x equals negative infinity to x equals positive 3. Those y values are increasing. Okay. Okay, questions? Okay, let's look at that absolute value function, number 4. This one's kind of like the quadratic. Part of the time it's increasing, part of the time it's decreasing. So I'm gonna, you know what, you can abbreviate increasing and decreasing. I wrote it out the first few times, but you can abbreviate it INC and DEC, so you don't have to write it over and over again. Before I write anything down, I'm gonna draw my line through the point where it changes from increasing to decreasing. This time it's right there on the y-axis, so it's happening at 0. I'm going to put my negative infinity over here, my positive infinity over here in case you don't already have it. As I move left to right, so starting at negative infinity, what's our function doing first? Decreasing. So negative infinity to 0, we are decreasing. 0 to positive infinity, we are increasing. Okay. Number 5 changes on us a couple of times. So let's go ahead and mark our places where it changes. One of them's at 0. One of them, I'm going to have to estimate that. Let's say that's 1.25. That's 1.25 right there where it changes. Okay, now this one, remember this one was a little weird because it didn't start over there at negative infinity. It didn't start until -1. So it starts by increasing. So at -1 until we get to 0, we are increasing. Then we decrease. So from 0 to 1.25, we're decreasing. And then from 1.25 until we stop, our endpoint there was 2.5, we're increasing again. So we have 2 increasing intervals and 1 decreasing interval. All right, last one. This one has some intervals that our other ones haven't. What do you think we call those flat places? Constant, okay? It's not increasing or decreasing, so it's remaining constant. So I'm going to put, we've got increasing. We don't have any decreasing, so I'm not going to put, I'll put it and put none. And then constant. Okay, so let's see here. Where do we change? We're changing. The first place we change is at -2. The second place we change is at +3. I think it's very helpful to start where it changes and draw that line, whichever direction you need to go to get to that x-axis so you can focus on the fact I'm talking about the x's. I'm not talking about the y's here. Okay, so we start out, we're constant. So our starting point, our starting y or x value was -5. So from -5 to -2, we're constant. Then from -2 to +3, our function increases. And then from +3 to our ending point at 8, we are constant. Notice if you've already identified your domain, then your increasing and decreasing and constant intervals together should make up that whole domain. So here's what I mean. -5 to -2, -2 to 3, 3 to 8. So I went from -5 to +8. You should get that whole domain in there when you combine all those increasing, decreasing, and constant intervals. Make sense? All right, so we're not going to do this for